So in this video, we're going to be talking about dihybrid Punnett squares. And this is the probability of having two traits. So make sure that you watch the video, Bozeman's video on Punnett squares, to have a better understanding of how to complete the Punnett squares, the dihybrid Punnett squares. So I'm going to give you another example. So let's say we have two heterozygous traits represented by A and B. So this is a heterozygous for A, heterozygous for B, crossed with heterozygous for A, heterozygous for B. And this will be the dad, and this will be the trait of the mom. So first we want to figure out what are all of the possible genotype combinations. And so we're going to do the distributive property. So big A can be with big B and little b. Little a can be with big B and little b. So the possible gene combinations are big A, big B, big A, little a, big B, and little a, little b. And so then you do that for the mom. Big A, big B, big A, little b, little a, big B, little a, little b. So you go ahead and write those out. Little a, big B, and little a, little b. So then you want to see how many different combinations are there. So I have 1, 2, 3, and 4. So this is going to be 4, and I have the same amount on the other side. So this will be a 4 by 4 Punnett square. So then I go ahead and draw. I have 2, 3, 4, 1, 2, 3, 4. So this is a 4 by 4. Now go ahead and put the dads. It does not matter which side. I'm going to put it on this side right here. So big A, big B, big A, little b, little a, big B, and little a, little b. You can also then you go ahead and put the genotype possible combinations for the mom. And then you solve. So in this square right here, you have the big A, and you also have the big A, and then you have big B and big B. And so then you go ahead and fill out the Punnett square. Big A, big B, little b. And so I suggest that you do this on your own paper so you have practice writing this out. Little b, little a, big B, big B, little a, big B, little b, big A, big B, little b, big A, little b, little b, little a, big B, little b, little a, little b, little b. So then, through here, you would say this is homozygous dominant for trait A, homozygous dominant for trait B, etc. And so then you would just read the genotypes as given. Another example, let's go ahead and say, let's go ahead and cross homozygous recessive with heterozygous, crossed with heterozygous and homozygous recessive. So first we do the distributive property. And so we do the different, first we want to figure out the different allele combinations. So little a, big B, little a, little b, little a, big B, little a, little b. And so I go ahead and write out all the different allele combinations. Little a, little b. And I notice that I only have 2 different allele combinations. So this is going to be a 2. And then I go ahead and do the distributive property for this. And it's big A, little b, big A, little b, little a, little b, little a, little b. And for this, I also have only 2 different allele combinations. And so I will have a 2 by 2. And so I go ahead and make a 2 by 2. And I put my 2 different allele combinations on this side and my 2 different allele combinations on this side. And I go ahead and I fill out the Punnett square. And using the genotypes in the squares, I go ahead and answer any of the questions. Are they looking for a recessive trait A and a dominant trait B? Then in that case, this would be the correct answer. So it would happen 1 out of 4 times.